So, good afternoon. I would like to welcome you all to this workshop organized in the frame of the GreeNest project on green architecture, aiming to promote construction with nature-based materials towards a future of buildings with zero emissions. We are a little bit late, as usual, and I hope that we will be able to catch up during the presentations. Professor Valentini Carvucci, who is the Vice Rector of the School of Architecture, is going to arrive a little bit late. So I will start by presenting the GreeNest project and the overall framework why we are here today. And then I hope by that time Professor Carvucci will be here, and she will be able to make an introduction on behalf of the School of Architecture that is hosting the event today on behalf of NTUA. So, as I said, the workshop today aims to promote what we call green architecture, how we can use nature-based materials towards a future of zero-emission buildings. What is the motivation? Why is renovation towards zero energy consumption and zero-emission building important? The European Commission has announced the Fit for 55 package, which is under the umbrella policy, which I'm sure you have all heard, the Green Deal. And in March 24, we had the revision of the Energy Performance Buildings Directive for the first time, aiming to progressively reduce greenhouse gas emissions and energy consumption in the EU building stock. We all know that the buildings account for about 36% of the EU greenhouse gas emissions, and a reduction of energy emissions as well as improving the energy efficiency of the buildings helps to lower the energy bills and fight the climate change. The new directive, which has started already to be implemented, requests that new buildings must be zero-emission buildings starting from 2030. And we have to take measures towards this direction. In addition, the new buildings that are occupied or owned by public authorities should be zero-emission as of 2028. In the emission calculation, member states should take into account the life cycle global warming potential of the building, including the production and disposal of the construction products used to build it. This is a very optimistic target, which is not purely and clearly defined yet. However, the Commission has introduced a definition of the zero-emission building as the building with a very high energy performance, and the very low amount of energy still required should be fully covered by energy from renewable energy sources without on-site carbon emissions. This sentence has a lot of challenges. How do we ensure that the building has the best possible energy performance without emitting emissions from the passive elements? And when we take into account the life cycle of the passive elements, obviously, as you can understand, we should take into account all the emissions that are generated during the life cycle of a material, of a system, of a component. And on the other hand, the other challenge is to have active systems, energy-producing system, PVs, building integrated PVs, heat pumps, plus, whatever else comes in the market in the near future, that have a minimum environmental impact. we all know that still all the active systems have a significant contribution environmentally, either due to the materials that are used or the working medium that it is used in the energy production, and the same applies also for the energy storage. So, in fact, although this regulation seems to be very promising in terms of the climate change, it has a lot of technological challenges. And the way we see it, it is very important to understand what nature-based materials can offer in terms of a green construction, a green architecture, and how these can be applied in the built environment. I'm sure that you all know from your professional experience that this is still at the first stages, the first steps, but at the moment in our hand we have a new regulation which we hope will help us promote this type of construction in the near future. So the reduction of embodied emissions, we define the emissions that relate to the envelope, to the shell of the building, are crucial towards the targets of the revised EPBD towards zero-emission buildings. We have to use low-carbon materials, including reused, recycled, and locally sourced biogenic materials, which can be naturally combined, and the nature-based materials are a first candidate in this direction. The other thing that we have to take into account is the so-called circularity index, which takes into account the carbon emissions that are incurred due to the reuse or recycling of materials or emissions, which are avoided due to exporting renewable energy while closed the life cycle and defining emissions beyond the life cycle. So practically this means when you have a renewable energy system that emits somehow, you have to balance this with the positive aspect of the embodied emissions that can be achieved via reused, recycled, and nature-based materials. This is not yet part of the regulatory framework. The regulatory framework is what I mentioned before, that from 2030, all new buildings have to be zero-emission buildings, and zero-emission means that we must use renewable energy sources for the local energy production, have a very well insulated and protected envelope of the building in order to reduce the primary energy requirements, use environmentally friendly materials in a more general term, as much as possible reuse recycled and locally produced material in order to reduce as much as possible the embodied energy of the building. Don't ask me what is the situation in Greece. I would not like to answer this at the moment. So, having made this very short introduction, I would like to present very briefly the GreeNest project. The GreeNest project is an EU-funded project that aims to develop an ecosystem to promote the zero-emission construction of buildings. In this project, we are 20 partners from 8 European countries that work together towards the achievement of this goal. And what is our overall goal? To be able to promote 100% carbon-free construction through the application of biogenic materials that can store carbon, to be able to demonstrate that we can reduce the embodied emissions by 50% with respect to the current net zero energy building standard, to minimize the energy consumption of new buildings constructed using renewable energy sources and low environmental impact material, to reduce the energy consumption to the NZEB standard, which translates to something around 30 to 50 or 40 kilowatt hours per square meter per year, and to reduce the greenhouse gas emissions during the operational phase of the building by 60%. In parallel, we realized that in order to be able to promote this type of alternative construction concepts, we need to be based quite a lot on local and regional value chains for the production, delivery of materials, for the assembly of the systems, for the assembly of the components. And a challenge here is to increase the productivity of the nature materials and the nature-based material envelope systems. So the productivity is a key factor, and we aim to demonstrate that this can be improved or increased by 30%. And to support the overall circular economy principles through the development of circular construction elements based on waste wood with reversible connections that can be reused or recycled at the end of the life, and to demonstrate envelope components or building components that can use recycled materials by 50% and improve their recyclability by 85%. These are very optimistic targets. We have started the effort 1 year ago, and we still have another 3 years to go. And the event today is part of the research work that it is done in the project. And we hope to be able to inform you a little bit more on these new approaches in terms of nature-based materials. The cost-efficient zero-emission building can be achieved by combining different technological as well as social aspects. What we want to do in this project to create a nested solution which will be based on a digitized platform and to deliver a unified ecosystem to allow the faster and wider uptake of zero-emission buildings. To achieve this, we are developing within the project 16 different standardized packages. We call them standardized packages. It's just an acronym. These relate to materials, to envelope components, to active technical systems, to control systems, and to IoT tools and digital platforms. These are the 16 standardized packages that we aim to develop as part of the project. You can see here at the material level, we aim to demonstrate the use of waste coffee that is otherwise disposed, filter coffee or any type of coffee that can be used to produce insulation panels. We are developing new methods for processing waste wood. We are promoting an earth screed-based component, which is coupled with waste double laminated timber. In addition to this, we are also promoting the use of lightweight clay modules. These are in terms of materials. These materials are combined to develop envelope components and systems, which we call smart wall. It's the third column to the right that you can see. The smart wall is a prefabricated facade system that will be demonstrated on the island of Lesbos in Greece, and it will comprise of local waste stone, locally produced mineral wool in a timber frame. The green wall, it's a combination of the smart wall with a green facade, aimed to be demonstrated at the municipality of Portoviro at the delta of the river Po near Venice, which is a cultural protected area, a nature protected area. And the aim there is to create a green facade wall that can be planted with local plants and be compatible with the environment. The Ecotech wall is another of the envelope systems that we are proposing to develop as part of the project that will be based on waste wood coupled with come on, Sina, help, or Simone. With natural fibers, yes. In addition, we are developing windows that can have the potential of energy harvesting, and that they have features, rotating features with low E-coatings to be able to manage the energy, the radiation and the energy transfer during winter and summer months. From the active system side, we are developing photovoltaics with low carbon footprint, heating and cooling systems based on heat pumps that have an eco-friendly refrigerant, and last but not least, a range of digital tools and indoor air quality sensors to be to help us to integrate all these developments and to, at the end, to monitor the buildings that will be constructed to demonstrate the achievements that we will have in terms of emissions. All the buildings that we are planning to use as demonstrators for the technologies are new buildings that are currently at the design phase. You can see here some pictorial representations of the buildings. The first building that we will demonstrate the developments in relation to the recycled wood, it's a flagship building that it is planned to be constructed by the Technical University of Berlin. It is a big building, and we will only design and construct part of the building with the developments of the project. The second building is a residential building in Berlin again, where we will also hope to be able to demonstrate the Ecotech wall. The third building is a fisherman's local resort or comfort building, as I mentioned, at the delta of the River Po in the vicinity of Venice in Italy. And the last one is youth center for recreation at the island of Lesbos, on the island of Lesbos, at the village of Stypsis. On the right hand, you see just an idea of what we are thinking of developing in terms of components in the project. What you see here is the earth-screed, earth-based floor and slabs, which are laminated, which use laminated and recycled timber. And in parallel, within the NTUA, within the Greek collaboration, the NTUA, together with Pileco, we are working to develop lightweight clay modules. You will hear much more about this during the presentations of the experts that are invited in today's workshop. So the long terms of the project, the long-term scope and impacts of the project, what we hope to achieve is 20% use of nature, bio, earth-based materials by 2050, to be able to demonstrate reuse of the building materials more than 10% by 2050, to reduce the material consumption and the need for building services through the innovative design by 10%, again, a long-term goal by 2050, to implement digital tools and monitoring techniques that will help to monitor and reduce emissions. Our target is to 18% by 2050, to use local renewable energy sources and to reduce the operational emissions of buildings, and to enhance the existing building utilization and user comfort. You can see that in this type of EU projects, we do not have one specific technological or architectural goal. We have a broad spectrum of goals that have to be synthesized and merged together towards the EU, towards achieving the EU policies and regulations. And this is a very brief presentation of the GreeNest project. I will be happy to answer any questions.